So the first thing that we do when we conduct a hypothesis test is we want to define the parameters. So mu1 and mu2, those are going to represent our population means. Remember, parameters always have to do with the population. So this would be all mothers who gave birth in North Carolina in that year, right? And we might even be using it to go broader than that, right? Maybe all in the US, whatever we sort of think is reasonable, as long as we think our sample is representative of that population. So mu1, I'm going to define as the mean birth weight of newborns with mothers who smoked, and maybe I should say, in North Carolina in that year. And then mu2 is going to be the ones who didn't smoke. Is that consistent with what I did before? I hope that it is. Yes, I set the smoking group to be group 1 and the non-smoking group to be group 2. It doesn't really matter which one you set to be which. We could have done it the other way around. The important thing is that you're consistent about it. So I need to be consistently always calling group 1 the smokers and group 2 the non-smokers. So in particular, the parameter that I'm interested in here is mu1 minus mu2. Right? The difference in the mean birth weights between newborn mothers who smoked and didn't, right? Remember this parameter, if it's equal to 0, that means that there's no difference between these two, that these two things would be exactly the same. If this thing here was a positive quantity, if we got, a positive number, that means that mu1, the mean for the smoking group, must be larger than the mean birth weight for the non-smoking group. If we go through and work this out and it were to give us a negative value, then that means that the mean weight of the newborns in the smoking group is smaller than the non-smoking group. Again, we can never know for sure. These are population parameters, so we can't actually calculate it out, but we're making hypotheses about it. So our null and alternative hypothesis here, the null is that there's no difference between the two groups. So I've got that mu1 minus mu2 is equal to 0. Remember, that's the same thing as saying that mu1 is equal to mu2. Okay? And our alternative here, okay, we're going to use that it's not equal to, meaning there is a difference between the two. For the alternative, we always have the choice of greater than, less than, or not equal to. And in this case, let's just go back to the wording of the problem here. It says that we would like to know if there's convincing evidence that newborns from mothers who smoke have a different average birth weight. So because it says different and not more or less, we're going to use a two-tailed test. And so we're going to use that not equal to sign there in the alternative hypothesis. Okay. Because this is a difference of means test, we're going to use this particular test statistic. Remember, we always have our estimate. So our best estimate of what mu1 minus mu2, the population parameter is, the best estimate is the sample means, the difference of the sample means. So we're going to use that as our estimate. This is our hypothesized value of that parameter under the null hypothesis. So we've got 0 there. So we're going to plug that in there. And then this is our estimated standard error. And that's going to follow a t-distribution with a certain degrees of freedom. I think for this one, I gave you 2 different degrees of freedom. There was a big monster. Let me go back here. There's this big monster of a degrees of freedom, or we can simply use this as a more conservative estimate. And I'm going to recommend that, especially when we're doing this by hand, that we use this approach. So in this case, that's what I'm going to use here. You should check out the summary sheet because it has a list of all the different test statistics for all the different scenarios. The tricky part is going to be figuring out what kind of test you need to do. And in this case, we need to do a difference of means test.